Hello everyone. Welcome to our channel I Can Learn. If you haven't seen our other videos, do check them as well. If you like them, then please give a thumbs up, share our videos and subscribe to our channel. In our previous video, we discussed some introductory key points of the chapter Atoms and Molecules, and we also went through two important laws of chemical combination. Today we shall be discussing Dalton's atomic theory. If you haven't seen our previous video, do check that as well, and if you like it, then please give a thumbs up. Dalton's atomic theory. The next problem faced by scientists was to give appropriate explanation of the laws. Both the laws of chemical combination were established, but it was important to give appropriate explanation of these laws. British chemist John Dalton provided the basic theory about the nature of matter. It was the British scientist John Dalton who gave the basic theory about the nature of matter. Dalton picked up the idea of divisibility of matter, which was till then just a philosophy. The idea of divisibility of matter was earlier given by our Indian philosophers and Greek philosophers as well. Dalton picked up the idea of divisibility of matter, which was just a philosophy and couldn't be established experimentally. He took the name atoms as given by the Greeks and said that these are the smallest particles of matter. His theory was based on laws of chemical combination. Dalton's atomic theory proved an explanation for the law of conservation of mass and the law of definite proportions. Both the laws of chemical combinations were easily explained on the basis of Dalton's atomic theory. Postulates of Dalton's atomic model. According to Dalton's atomic theory, all matter, whether an element, a compound, or a mixture, is composed of small particles called atoms. The postulates of this theory may be stated as follows. According to Dalton's atomic theory, every matter, be it an element, a compound, or a mixture, was composed of smaller particles which were termed as atoms. We shall now be discussing postulates of this theory. All matter is made of very tiny particles called atoms. Atoms are indivisible particles which cannot be created or destroyed in a chemical reaction. While discussing introductory key points yesterday, we also came across a point where a philosopher suggested that after dividing matter multiple times, we shall come to a point where it would not be divisible any longer. Hence, atoms are those indivisible particles which cannot be created or destroyed in a chemical reaction. Atoms of a given element are identical in mass and chemical properties. Atoms of different elements have different masses and different chemical properties. For a given one particular element, atoms have identical masses and identical chemical properties, but if they are atoms of different elements, they have different masses and different chemical properties. Atoms combine in the ratio of small whole numbers to form compounds. The relative number and kinds of atom are constant in a given compound. These were the postulates of Dalton's atomic model. Let us now discuss what is an atom. We all have observed a mason building walls. From these walls, a room, and then a collection of rooms to form a building. What is the building block of a huge building? What about the building block of an ant hill? What could be the smallest unit from which a huge building is being made? Well, we can say probably a brick or something even smaller. What about the building block of an ant hill? It is a small grain of sand, as we all know. Similarly, building blocks of all matters are atoms. The smallest unit of all the matters can be considered as atom. Let us now discuss how big are atoms. Atoms are very small. Obviously, atoms cannot be seen with our naked eyes. They are smaller than anything that we can imagine or compare with. Nothing is as small as atom from which we can compare its size. More than millions of atoms when stacked together would make a layer barely as thick as any sheet of paper. Its atomic radius is measured in nanometers. That is, 1 meter is equals to 10 to the power 9 nanometer. 1 nanometer is equals to 10 to the power minus 9 meters. Therefore, we can only imagine that how small is the size of an atom. Moving on, let us now discuss what is exactly an atomic mass. The most remarkable concept that Dalton's atomic theory proposed was that of the atomic mass. While discussing Dalton's postulates of the model, we came across the term atomic mass. We shall be discussing that in detail now. According to him, each element had a characteristic atomic mass. The theory could explain the law of constant proportions so well that scientists were prompted to measure the atomic mass of an atom. This theory was so successful in explaining the law of constant proportion that all the scientists wanted to measure the atomic mass of an atom. Determining the mass of an individual atom was relatively a difficult task. It was very difficult to determine the individual atomic mass of an atom. Therefore, concept of relative atomic masses were determined using the laws of chemical combination and the compounds formed. Let us now discuss atomic mass with the help of an example. Let us take the example of a compound, carbon monoxide, formed by carbon and oxygen. It was observed experimentally that 3 grams of carbon combines with 4 grams of oxygen to form carbon monoxide, that is CO. In other words, carbon combines with 4 by 3 times its mass of oxygen. Suppose we define the atomic mass unit, earlier abbreviated as AMU, but according to latest IUPAC recommendations, it is now written as unified mass, as equal to the mass of one carbon atom. Then we would assign carbon an atomic mass of 1.0 U and oxygen an atomic mass of 1.33 U. However, it was more convenient to have these numbers as whole numbers or as near to a whole number. Well, from this example, we can see that initially atomic mass assigned to carbon was 1.0 U and that to oxygen was 1.33 U. But it is very obvious that it is more convenient to have these numbers as whole numbers or something near to a whole number. In our next video, we shall be discussing that why it was important to have atomic masses as whole numbers. That is it for our today's video. In our today's video, we studied about how Dalton came with the idea of Dalton's atomic model. We discussed various postulates of the model. We discussed what is an atom, its size, and we also discussed about atomic mass. If you like our videos, then please give a thumbs up and subscribe to our channel. Thank you.